Hey, hello everyone. Hey, Oleg. Thank you for coming. Can you hear me? Can you hear me? Yes. Okay. Okay. Thank you for coming. We can wait another 1 minute, maybe. Today, I'll talk. Firstly, I'll show how to use Jupyter Hub, and then we can discuss the machine learning problem or the quiz one related problems. I'll first take some time to introduce Jupyter Hub. I'll share my screen now. Can you see my screen? Yes? Okay. Yeah. Yes. Okay. Jupyter Hub is the platform for our university students or teachers to use for computing or programming. If you have a valid art account, you can log in with your account. And it's very good, actually. Everything set up very well. If you haven't tried, I think you should have a try. And now I will show you how to use it. I'll restart. This is, I'll copy this here. So this is the address. Sorry. I should give everyone. Can you see the address? And then you'll be asked, you will have to choose a server. I'll also copy this here. Basically, we will choose the first one, at least for this course. And then we will start. What okay, can you see the server now? As the professor has mentioned in the lecture, we'll minimize the effort of coding, but a lot of lecture materials will be written in a notebook. So I'll introduce a little bit about this. All the code are written in Python for this course. And now I'll go to download the notebook and the dataset we'll use for round one. From here, you can see this notebook and the CSV file. This is a dataset, and then another notebook about law of large numbers. I have downloaded them in advance, so I won't do it now. You just click it and it will automatically download it to your local directory. And then we will try to upload these files. First, okay, I'll go back to the notebook. But basically, you should put all your files under the under notebooks, and don't change the other directories. They won't be persistent for you. only put your files for your projects in under notebooks, and you can always create a new folder. For example, I'll rename it as round 4. Okay, I already uploaded them here, and for uploading files, you click this icon, upload files, and then choose the files you want to upload from your local directory. I have already uploaded them, so I'll cancel this. And if you want to create a new notebook, you choose, well, I'll use Python for programming. I'll choose Python. And now we can have a look at the first one, this one. This one is related one of the quiz question. I guess you may have already seen the question. Asking you to calculate the temperatures, minimum or maximum average. A notebook in Jupyter Hub, all the packages are already, most of the commonly used packages are already installed. So the first thing, we just import these packages. There are a lot of useful packages. Sometimes people call them libraries for using. You don't need to do this, but if you are curious or interested with this, you can exploit yourself. The package we use here is called Pandas. It's a package for a very useful package for a lot of calculating and to manage your data set. I will use Control and Enter to run the cell, or you can also click this triangle button to run the cell. Control and Enter or Shift and Enter. Use Shift and Enter, it will jump to the second cell. And after import the package, I'll read in the data file. This is the only thing you need to change for this course, for this task, is the file path. But usually a good habit is to put the dataset together with your notebook. Given you are doing a small project, you always put the dataset in the same folder with your notebook. Then you just you just put the file name here and run this cell. It will be read in. And if you put it somewhere else, you can also here is the path. You can copy the path. I may have a try. Yes, I can also use this. No such. I'll use this. I think that's because we are working under round 1 in this directory. If you are not here, you can use the different the copied path, I think. Actually, you can check where are we. Yes, no, yes, we are here. Don't need this. So if you are already in the folder, then you just use a file name. That's okay. And then I'll use this hide function to have a look at the first 5 records of the data set, then you will have a sense how this data set looks like, which column is the one you're interested in. Here, the air temperature is the column we are interested in. We want to use this column to do some calculation. And as the column name is air temperature degree Kelvin, that's too long. I'll change the column name by using this function. Then I'll get a shorter one. And then use these functions, you can calculate the average temperature, minimum, maximum, and the standard deviation. And then you can answer one of the quiz question. So this is a simple one. Basically, only thing you should do is make sure the file name, the file path is correct. And any questions about this? Is it clear? It's okay. Okay, then we'll go to the next one. Okay, the next one is the law of large number. Oh, sorry, not this one. Yes, this one. Okay. About the law of large number, I don't know. Maybe some of you are very familiar with it, but I think I'll take some time to say a little bit about law of large numbers. I'll share my whiteboard. Can you see my whiteboard? I guess I think you can see it. Yes, okay. I'll say a little bit about law of large number. As the professor has mentioned before in lecture that we're trying to minimize probability theory for this course, but there are two very important concepts for machine learning. The first one is we call the IID, which is independent identical distribution. This is a very important assumption for machine learning. Usually we will assume that all the data points are from an identical distribution and they are independent from each other. So that's the first concept, very important for machine learning. And another one is the law of large numbers. Suppose we have a distribution, or sometimes we also call it a population. The elements in this distribution or population, usually they are infinite or very huge numbers. It's important. It's impossible for us to exhaust all the elements in this population, or I should say distribution. So for machine learning or for many the other experiments, we will just draw a part of the data from it. Say we will take x1, x2, x3, the xm. We will sample m values from this distribution. They are all from this distribution, and they are independent and identically distributed. That's what we call. And then we will calculate their average, which I will denote it as XM bar. It's the average of this independent identically distributed random variables. X1 plus X2, X3, XM. This is what we call sample mean. And for machine learning, we also call them empirical mean. This XM bar, this sample mean itself is also a random variable. And for this distribution, the expectation of xi of each random variable, we set it to mu. And the variance of this distribution is sigma squared. And according to the definition of sample mean, we can easily calculate that the expectation of XM bar is also mu. And the variance of it is sigma squared divided by m. Okay, and then I will plot a graph to show you how this exactly look like. We should be noticed here. M is divided by m. So when m getting larger, this variance of sample mean will get smaller, right? A smaller variance means less fluctuation, right? I'll try to plot a graph to show you how it looks like. See, the x-axis is the sample size. We call it sample size. Means how many data we draw each time. And see, mu is here, which is the expectation of the distribution or population. And then say when I'll use a smaller number firstly, say it's 10, and then I will get x1, x2, x10. I will calculate their average, and then I will get a point. Say maybe it's a little bit smaller than mu. Say it's here. And then I will repeat this process. I'll get another 10 elements from the distribution and calculate their average again. And see, I get another average, maybe it's here. And then I will repeat this process many times. And I will get a lot of different average, right? They will be like this. They will be fluctuating up or down around the mu. And then I use a different sample size. Say I'll use 100 or 1,000. And then I'll get another series of sample means, which will also be fluctuating around mu. It may look like this. And then I will I will use even larger sample size. Say I'll use 10,000 or 100,000. Then I will get another series of sample means. But this time sample mean will be very, very close to mu. It will be like this. So this is what law of large number is telling us. It's telling us that the sample mean will converge to the expectation as the sample size m go to infinite. This is what law of large number is telling us. I hope it's clear. If not, I think you can also read the markdown text in the notebook, and also we have a question here. Is sample mean same as average? I'm not sure I understand this. Okay, sample mean is same as average. I mean, average of sample mean is the average of this. Okay, I'll say it again. Sample mean is, we call this 10 values sample, right? So sample mean is the average of this 10, we call it realization or observation or element. Sample mean is the average of these 10 values. Is that clear? I use average or mean. They're the same meaning here. And the mu, usually we will call it, for mu, usually we will call it the expectation of the distribution. But actually it's also a mean, right? I think you lost the whiteboard, right? Okay. Now you can see the whiteboard, I think. So basically average and the mean, there's the same meaning here. I'll call this mu as expectation. Okay, and you can refer to some possibility theory textbooks. Let's go back to the notebook. Share the... Okay, then we're this markdown texts are also about law of large number. Please take your time and go through them carefully. This is really an important concept for machine learning. And this notebook also basically also showed the same process I just did on the whiteboard. In a different way, in a coding way, in a programming way. But basically they are saying the same thing. There are two tasks here, but they're not related with our current quiz 1. You will see them later for another quiz, maybe quiz 2 or quiz 4. You will be using this notebook, and I'll briefly go through this. This first also import the packages, and then this is a mu I just used before on the whiteboard, and the sigma is the variance. Sorry, sigma is the standard deviation. Sigma squared is the variance. And m is the sample size. I just select, I changed it from, you can feel free to change it to 10 or 100 or 1,000, but if it's larger, it will run for longer time. but feel free to change this configurations to have a look at how these data points will change. In this notebook, we use Gaussian distribution as the distribution from which we draw data points. You can also use the other distribution. And this is a function. This is a function with which we draw our samples. And this is all of the samples you draw. See, the average is 10. They are fluctuating around the 10, up and down. And then we will calculate the average of these 200 values. And then we will get one value, right? And then one value, for example, the one value is corresponding to 0 here. And this process was repeated for 100 times. You will get 100 sample means. They all are around 10. But if you change the value of m, here we use the 200. If you change this 200 to say 2000, then this value, these points will looks like more compact. They will more closely around 10, around the expectation of the distribution. These tasks, you can try them now, but later you will see them in another quiz. Oh, sorry, didn't see it. We have some questions. Is this notebook also need to answer quiz? No, currently no. This notebook helps you to, thank you, Oleg. Yes. Okay, I think for Jupyter Hub, it's okay. Okay. Yes, and then have you any questions about the your machine learning problem assignment or the questions in quiz 1 or anything relevant with round 1? Quiz 1 is related to the exercise at the end of the chapter. To the actually no. Well, there's some similar thing, maybe some similar question in the exercise of chapter 2 with quiz 1, but you don't need to. Sorry, but you don't need to work out the exercise in the course book. But it will be good if you check them and try to solve them. Actually, they are kind of more difficult than quiz 1, I think. In your machine learning problem, I don't understand the concept of question 8. Predictor map. How do I come to a conclusion? Predictor maps. Quiz 8. Okay, let's have a look. Quiz 8 is Quiz 8 is in machine learning, we often distinguish between two groups of properties of data point. Are you talking this one? I'll share my screen. You can see my screen, right? Yes. Okay. Are you talking about this one? The question 8. This one? Dog. No, it's not that. Yeah, I think they randomly shuffled. Yeah, 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 sure, please. I'll change the setting. Now you can share your screen.
Okay, hello.
Hey.
I cannot share my screen while you were
Yes,
sharing
yes,
it.
I'll stop my sharing, then you can share your screen. Quiz. Okay, I'll try to explain it. I'll share my whiteboard now. Okay, that's according to the statement, you're asked to map X, which is a real. This is a real value number, right? And then you're asked to transform it to a vector. Actually, you use 4 different indicator function, which is phi1, phi2, phi3, phi4, phi4. You're asked to use these 4 indicator functions to transform X into actually it's called linear nonlinear maps. What's the interval? Sorry, I will. I have to find the question. Which one in my course? Yeah, I found it. The interval is for phi1 it's -10 -5, and then -5 0. This is round parenthesis, and then 0 to 5, and then 5 to 10. And actually, by using these 4 indicator functions, X will be mapped to a vector. See, if X is in the interval -10, sorry, in -10 to -5, then you will get 1 for the first position, first entry of this vector, which corresponding to, this is actually phi1, right? And for phi2, phi3, phi4, you will get 0, because as X is not in that intervals. But if X is in -5 to 0, it will be mapped to a different vector, which will be 0, 1, 0, 0. 0. These 4 elements corresponding to phi1, phi2, phi3, phi4. And after X being mapped to a 4 entries vector, and then the vector will be input to the function of hx, which is like this: j equals to 1 for w1 wg phi g of x. This actually, if we write it in matrix format, it will be like this: w1, w2, w3, w4. This is a row vector. This row vector multiplied by this. There's no name for the vector of features. maybe I'll give it a name. I'll call it Z. This vector Z, it may be 0, 1, 0, 0. And then the row column, the row vector multiplied with this column vector, then you will get that's Hx, right? And for x smaller or smaller than -10, this vector will be 0, 0, 0, 0, right? Or x larger than 10, it will also be 0, 0, 0, because it's not in either of the intervals. And if we plot them in the coordinate, it will look like this. Say x is from 0 to 5. This is 10. Oh, I should draw the -5, -10. For all of the x in this interval 0 to 5, they will be mapped to a same vector, right? And then they will be, say, they will be mapped to the vector 1, 0, 0, 0, and then multiplied by W1, W2, W3, W4. And this is comma. All of the x in the interval 0 to 5 will be mapped to a same vector. And you will end up with a same h of x, right? And then maybe h of x is here, or maybe here, or somewhere else. That depends on the value of w. I got some questions. Sorry. Can you see the whole screen? I think there's some, it's delayed a little bit. Let me see another question. Look. Yes, this question looks very similar to exercise 2.5, 2.6. In your machine example summation to assess are the correct answers to the example report. List and potential. Example summation to it are the correct answers to the example report. Namely, the correct answers to criterion 2 and 4 seem to me to be incorrect, as the problem statement doesn't discuss features at all. It doesn't list an answer instead of not, but answering yes instead of no to the questions. Sorry, I don't know how this one looks. This example summation looks like. I'll go to there, have a look later. Maybe Dorma, could you please maybe send me an email? I need some time to check this question. Okay, thank you. And let's continue with this question. Yes, this one is very similar with the course book. So that's to say, you first map x to a vector, and then you use w, a series of w, and multiplied with the vector, and then you will get your h of x. That's how to solve this question. And for a different interval, say interval in 5 to 10, you get a different vector, and you. Could you please explain how to solve this one? Okay, I'll get to this later. And let's continue this one. For x in 5 to 10, you will get a different hx according to the values of w. So I think that's all I can say about this. Okay, okay, let's move on to another question. Consider the tiny, this one. Consider the tiny desk. Assume we want to implement. Yes, each hypothesis represented by the of all the weights. Let's assume that how many different hypotheses can we store in the? Yes. How many can we store? Yes, this question is like this. N equals to how many? Oh, sorry. It's off. Can you see the whiteboard again? No? 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 Okay. What happened? Okay, yeah, it's there. Yeah. N equals to how many zeros? 6. Okay, and assume that 1 gigabyte. Yes, a total of 8 bytes. Was it represented by space of all the weights? Let's assume each weight is yes. So each weight is quantized using 8 bits. So together it will be 8 multiplied by what's this? 1 million. Then it will be 8 millions. And then 100 and then sorry. 1. And the storage of the Raspberry Pi is 10 to 9. This is 10 to 6. 10 to 9 bytes. So, we don't need to multiply this actually. It's already in 1 byte. And then that's divided by this number, you get the solution. No, it should be multiplied 8 here because we have 8 gigabytes for the Raspberry Pi. So this is the total memory, the storage of your Pi, and then you have to store all of this these weights there. Then divided these values, you will get the solution for this one. And then let's see. What's the time? Do you want to have a break or we can continue? We can continue. Okay. Then I'll talk a little bit. I'll give a little bit examples of machine learning. Your machine learning problem. As I saw some, some of the summations. There are a little bit mistake maybe somehow. We know for machine learning, we're trying to solve prediction. We're trying to solve prediction problems, but I saw some summation kind of they're kind of just a calculating problem. For machine learning problem briefly, because yes, sure. Okay, I'll continue this one. For machine learning, we're trying to solve a prediction problem. We're trying to predict something from features, given features. We're trying to predict our label, right? That means we don't know the map. What's the map, or I should say, hypothesis function. Sorry, I'm sorry for the whiteboard. Unsupervised learning. For unsupervised learning problem, we're not trying to make a prediction because you don't have label. Let's focus on this assignment firstly, and we can talk unsupervised learning later maybe. We're trying to find. I think you can see the whiteboard, right? It's always like this. I'm sorry for this. For this assignment can't be unsupervised learning. I think you're supposed to specify the feature and the label. If it's unsupervised learning, there is no label, right? I think for this assignment, as I understand, it should be unsupervised learning. So we're trying to predict a function. We will try to come up with a function. Usually we can call them hypothesis function. They are from the functions from hypothesis space, right? We're trying to find the optimal function from the hypothesis space. That means you don't know the function. But I saw some summation. Their problem, they're not prediction problem. They're actually calculating problem, because sometimes you know the function. If you know, maybe you don't know. I don't know, but the experts in that domain, they know the function or the formula for that problem. Then it's not a prediction problem. It's just a calculating problem. So we should make it clear what kind of problem is prediction. You're trying to find this optimal function, which you don't know before you learn, before the learning, before the training of the model. Okay, and my machine learning for this assignment complete. Wait a moment. I'll give some examples, because someone asked me about some special ones. I'll talk a little bit. The first one I want to talk is images. I saw a lot of summations are related with image. Well, I use a very simple example for handwriting recognition. This is a very simple application, and but it's very useful. For example, you may write a number 7. here you want the computer to recognize it as a very I recognize it as 7, because sometimes you may write it in a very messy way, say like this or something else. Then this data point is a picture or image, right? And the feature is the intensity of each pixel, right? So it will be transformed into a real number matrix, say 0 for white, then it will be like this, a lot of 0, and then 225, 255, 255, or like this. 0, and the other place 0, 0. I'll use another color, maybe it will be clear. 0, 0, 0, a lot of zeros. So this is a matrix. I don't know, maybe it's an n by n matrix. One of you asked me about how to processing images. Actually, I never used Excel for machine learning. I don't think you can handle this problem with Excel, but I will ask a professor about Python programming, because we're not supposed to use any code in this course, but for the final project, actually I'm not. I also don't have the answer now. I'll ask him. Try to explain if some of you want to use image as a data point, some problem related with image processing, and well, basically, for if you use Python, then there are a lot of very useful packages can help you to easily transform the picture into a real value number matrix, and then the input will be a matrix, and the label will be for this digit recognition application. The label will be a number from 0 to 9. Then it's a multi-classification problem. It will be like this. These are all numbers. These numbers will be inputted into the model, and then you will come out. You will come up with a real number for the label. You will use a lot of W, a lot of parameters W. A lot of parameters, and this is for images. I'll make it clear if we're not supposed to use Python coding, how we can come out with this kind of problem for our final project. And this is very simple one. Some of you may be interested in music. I saw some summation is about music. For music, the feature, well, the data point may be a song or a piece of music, say 3 minutes clip or something like this. And the feature will be like this, because we call this kind of data time series data. The horizontal axis is time. I'm not sure it will divide it maybe 0.1 second or 0.2 second. So a series of time. And for each time point, there will be a corresponding amplitude, right? It will be maybe higher. And this will be corresponding to a number. Say maybe the first number is I don't know, 0.7, or next one higher 0.9, and 0.1, 0.3, maybe 0.8 or 1.7, a series of real numbers. Well, actually, this is the feature, which is for the data point x1, this will be x1 subscribed 1. This is, this 1, 2, x1, 3, x1, 4. So this series of numbers, this is the feature for music. And then, but this kind of feature, you cannot switch their positions. But for maybe for the other applications, the position of features that doesn't matter. You can switch them. For example, weights or heights or ages. Then you can switch the position of features. But so for this kind of application, you can't do that because they're time series data. Because this, but for music, it's like this. Say you give the computer a fragment of music, a clip of music, then it will try to classify them to a different genre of music. Say it's classical, or it's pop, or rap. You will, this will be the labels, right? Say you will represent the classical, use 0 and 1 and 2. So it is also a multi-classes, classification problem. So that's for music data points. And another mainly used one is natural language processing, say texts. I also saw some question about the texts. For texts, for example, a very simple one is called a sentiment. I'm sorry, it's you can't see the whiteboard, right? Oh, sorry for this. Now you can see it. For texts, a very commonly used one is sentiment. It's called sentiment analysis, which is you try to analyze the sentiment from a given sentence. Say something from customer reviews. For example, I'll say this movie sucks, or I say excellent restaurant. I'll definitely come back later. So this kind of customer reviews, you will try to analyze them and predict. You predict it's good on or bad. It will, for example, a binary label. Say 1 is for it's a good restaurant, or 0 is a bad one. And the label can be like this. The label can also be like in you give the rating the, say, the restaurant 1, 2, 3, 4, 5 stars. So you give the input is a sentence or several sentences. You try to give the rating of the they say restaurant based on these texts. But these texts will also be transformed into numbers. That will be, say each word will be represented by a vector or matrix. If you are interested in this one, I think you can easily find some materials from website, from web, from Google or somewhere else. But usually, for example, I use a very simple one is use dictionary, in English dictionary, say A is the first one will be represented by a number 0 and maybe another, I don't know, the second word in the dictionary, say apple, maybe it's represented by 6 or the last one, zebra. I don't know if this one or not. It may be represented by a very large number, say 10,000 or something else. Then the words will be transformed into real numbers with this real numbers as input. You will implement your model to solve your problem. This is also time series because the order of this words means a lot. And that's music, language, and the image. Okay, I will give another example. Maybe because I saw one of the summation is about a recommendation system. This kind of application is very popular to trying to recommend products to customers. For example, let's say you're trying to build an application for a bookstore, an online bookstore. Then you will explore the history of customers' shopping history and sorry, it's always like this. Okay, for recommendation systems, data point is the behavior of a customer, shopping behavior of purchase behavior of a customer, and the feature could be, for example, the customer's purchase history. Say, for example, 6 days. How many books he or she bought for the past 6 days, 10 days, and which categories these books belong to, and then try to predict this could be the feature. And you try to predict the label. The label could be you're trying to predict what kind of books this customer will like. Then you can recommend this kind of book to he or she. Then he probably will buy it. So label will be, say, sorry, it's frozen. Yes. Say customers' preference will be the label. Let's get some concrete example. For example, I will say, for the past 10 days, a customer bought one book about maybe music. Say one book about music and another maybe fictions maybe 2. If they have a kid, then it will buy some book for kids. Say this customer bought 10 books for kids. Then we, from this kind of data, you can predict the customer's preference, right? And you should formulate the label then. The label could be, say, maybe what kind of book what kind of book the customer will buy for the coming days, maybe also 60 days. For example, I will say for the following 60 days, the customer also bought a music book, maybe 2, and fiction, say 3, and kids book, maybe 5, and about sports, maybe 0, about cooking, maybe 1 or 2. This kind of, this will be the label, but usually we can normalize them. Then we will say maybe 50% of the books are for kids, and 30% is fiction, and 20% is music. And this is a label. This could be the label. So basically, you have to make all of the features and the labels into numbers. You have to quantitize them. I saw some summations. Well, it's not. Sorry. Oh, why is? Okay, so basically, you should make them formulate the features and the label in for real value numbers usually. I saw some summation specified how the features or label will be represented by numbers. That's very good. I personally think it will be better if you specify what kind of numbers you will use, especially for some applications that are not so obvious for everyone. It will be better. You tell people what kind of numbers. Say we will use a range. For example, I will say one feature about say how you feel about a movie. Then you can use a number to represent your feelings. Say 1, it's not good, and 2, it's okay, 3, it's good, 4, it's perfect, something like this. It will be better. And I think that's enough. We have 4 different examples for different kind of applications. Let me see. Is there any question I didn't answer? No, I think I answered all of them. Okay. Do you have any other questions? Just one last answer. One last answer. This one? Unsupervised learning. I think in this course, unsupervised learning, it's round 5. Round 5 is about unsupervised learning. You will see some quiz for some assignment for that round. But for this, your machine learning problem, don't use unsupervised learning project. You have to specify the labels, so don't use that. For the dataset I found in the internet, can I pick out whatever features or column I like to use and mention it? Can I just ignore that rest? Yes, actually, it's a good question. Actually, you download some data from the internet, or sometimes you scrap some data from the website. and then you will get a lot of features. You don't need to use all the features. Actually, you will learn the concept which is called feature selection. Feature selection is very important. Actually, I think the professor will talk about this. But the good method is you select features under some principle, not just randomly give up some features. But for this assignment, well, it's okay. You are not supposed to be very good at feature selection. You can specify some of the features in the assignment text, and don't mention the others you are not interested in. A very simple way is you select that features which are related with your label. Sorry, I'm really sorry for this. Maybe
can I ask another question? Yeah, I asked that.
Yes.
Yeah, can you hear me? Yes. Do I need to explain my choice for the future?
Sorry. What did you say? You.
Yeah. Do I need to explain my choice for the future? Like if I select some feature to use, do I need to explain why I choose it?
Well, you can explain them. Someone describe this problem clearly. What kind of feature you want? I think that will be better. It's not required, but it will be better if you specify the reason which features you want to choose. It would be better. We will encourage you to do this. That's it.
Okay. Yeah, thank you very much. Yeah.
You're welcome. Let me see another question. Can I just yeah, this one. How many questions are there typically in a quiz? I don't quite know about this. I think maybe around 10 questions. Is regression supervised? Yes, definitely, because regression, by the word regression, you will get something, get a label. Usually it's a numerical value, so it's supervised learning. I can give some example about unsupervised learning. Actually, in the recommendation system I just talked about, usually sometimes in that system, unsupervised learning will be included. Say I have some data point. Say I have some data points representing customers and their purchase history. They bought some books, and we some books about art, some books about music, some books about cooking, some books for children, and then we don't use any label. We just try to classify these customers according to what kind of books they bought. And maybe we will say, this people, maybe this is a housewife, or this is a college student, this may be a businessman. We will do this kind of classification without any label. That's unsupervised learning. So you see the difference. I'm trying to solve the book exercises. How could I get some help with that, especially with some concepts math? Since I have solved some of them, I would like to know if my answers are correct. Yes, there's no answers for this. I asked the professor, and because I'm not sure my answer is 100% correct. But if you have any questions, you can ask in Zulip. But I will ask Professor Jung. Maybe he can give some correct answers for us to refer to. But the questions in the book it's kind of difficult than the quiz. But it's good if you want to solve them. That's very good. But maybe you need some calculus or more probability theory or linear algebra knowledge. That's up to you. If I mean, some of you may be very interested in coding, then it's good. You can try to use some Python packages to use notebooks to solve your project. That's very good. And maybe some of you are interested in the math because behind these applications. Actually, there are a lot of things to learn in machine learning. About let me see another question. I've noticed that someone else has introduced quite advanced topics like the representation loss function. I thought a face-to-face session for discussion. Yes, actually, yes. If you want to know the answer of this in quadratic, I don't know. How familiar are you with linear algebra and calculus? It will be well for that question. Actually, I can give some brief explain. We have some time. Let me see if we don't have more questions. I can give a brief explain to that one. Do I need to upload the Python file every time, or it's saved? You don't need to upload it every time. You just put it under the notebooks directory. Then it will be there for you because you don't put them in the other place. You uploaded on Tuesday but can't find it. That's weird. I think you obviously signed in with your account. That's yes. If you want to install Jupyter on your own computer, it's okay. You can. I recommend use Anaconda. You can try to install Anaconda, then you will get a notebook and the other very commonly used softwares. Yes, but I think you should also try to use Jupyter Hub. It's a very good platform. But you couldn't find the file. That's strange. Let's see. I'll stop this one. Share screen. You just make sure it's under the notebooks. I think it will be there. Let me see another question. Oh yes, very good. Thank you very much. Thank you, Maria. Yeah, here. Sorry, didn't see you. Thank you very much for coming. Yes. Oh, sorry, I spelled it wrong. Yes. Thank you very much, Maria. Install your own computer. Okay, any other questions? If not, we have some time. I'll try to answer the question about this quadratic form representation of the loss function. As we have just learned the loss function, actually, it's good to know a little bit more about this. I'm trying to share my whiteboard. You can see the whiteboard yet? Okay, this one. Another option, Google Colab. Yes, you can also use Google Colab. Thank you, Oleg. Okay, I'll try to explain this, but yeah, the loss function is, it's a function of W, right? In this function, actually X and Y should be viewed as parameters. It's this, it's I equals to 1 to M. We have M data points. Yes, it's this W transpose X I minus Y I, right? And squared. Yes, this is the loss function. It's I'll write it in matrix form. It will be like W transpose W transpose X I minus Y I. No, not like this. It will be see, W transpose is W transpose. Yes, W trans X1 minus Y1. W transpose. No, not like this. Sorry. It should be W transpose X1 minus Y1. This is the first element, and the W transpose X2 minus Y2. W transpose X3 minus Y3. To W transpose X4 minus Y4. And then this is the row vector and multiplied by its transpose. Its transpose a W transpose X1 minus Y1, and the second is transpose X2 minus Y2. Let's focus on the first, the row vector. And it will be, I will write into another form, W transpose X1, W transpose X2, W transpose X3, W transpose XM. This is a row vector, right? And minus another row vector, which is Y1, Y2, Y. Oh, sorry, it's not 4, it's M, the last one. It will be like this. This is this one. They are equivalent, right? Just a row vector minus another row vector. They are equivalent. That's okay. And then as for each element, there's a W transpose here. I will factorize it out, pull it out. I'll use this one. I'll get it outside. Then I'll get this X1, X2, XM minus Y1, y2 ym. So this is the first part. I didn't put the transpose here. I will get to this later because it's just the transpose. This is just the transpose of the first term. And then I will, let's see this. This is this is a row vector, but actually it represents the whole feature space, right? Every feature of every data point is here. It's actually the feature matrix X. It should be X transpose. The uppercase X. I use uppercase X to represent the whole feature. The whole feature feature matrix, which is I will make it more clear. It will be x1 1 x1 2 x1 n. Yeah, we suppose we have n features. We have n features. Then this will be x2 1 x3 1 xm1. We have m data points, so this matrix is m by n, right? But we put it here. It will be X transpose, which is n by m. This is you will if you look at some book for machine learning, you will always see this uppercase X. It representing the whole, the entire feature. I would say feature matrix. All of the features in this data set of each data point will be involved in this matrix. It's quite a useful notation. You will always see this. And okay, I'll keep this. We have n features, m data points. I should specify this firstly. We have n features and m data points here. So this actually it's X transpose. That's why we X transpose is an n by m matrix, and then I will write it like this: W transpose X transpose. This is uppercase X, representing the whole, the entire data set. And then minus what's this? This actually is Y transpose. I use uppercase Y to represent Y. Uppercase Y is all of the labels: Y1, Y2, ym. It's m by 1 matrix, but its transpose is 1 by m, right? 1 by m. And I will clear this. That means this actually is W transpose X transpose minus Y transpose, right? But this is just the first. This is the first item. This one. Don't forget the transpose. Don't forget its transpose, and then its transpose will be. So its transpose is W transpose X transpose minus Y transpose, and then transpose, right? So this is now it's the loss function is like this, and then I will move on. Okay, it equals to a W transpose uppercase X transpose minus Y transpose, and then Either transpose outside and inside according to the linear algebra. I can write it in this form. XW minus Y. Then all the transpose dropped. But the switch the position of W and X. This is according to linear algebra rules. Now we get this formula, and then we can expand it. It will be W transpose X transpose X W. This term and this term, multiply them together, and minus Y transpose X W, and minus W transpose X transpose Y. And don't forget another, the last one, Y transpose. Oh, sorry. Where did the second term come? Oh, the second. Sorry, wait a moment. I'm trying to. What is the second term? The second term, you mean the transpose of the first term? Oh, it's so slow, sorry. Okay, I think you can see it now. We don't lost everything. No, we don't. Okay, you asking after the matrix X and Y were explained. You're asking about this second term, right? This term. This second term. Yeah, because this is this part. Because it's here, see, it's how to say after the one. I'll explain this a little bit. See, let me use another example. See, we have a matrix A, and A is A1, A2, A3. I use a simple one. A1 squared minus plus A2 squared and A3 squared. This is A multiplied by A transpose, right? So that's why this is actually 1 x I to 1 to 3 AI, right? It's exactly the same as our loss function. It should be A transpose and A multiplied by A transpose. That's why here we need this transpose term, and this term is this one. Well, I didn't derive this part because it's exactly the transpose of the first term. I just derive the first term, then you will put it here and adding a transpose. And yeah, I just derive the first term of this matrix multiplication. And now we get this. We will get this one. We get this this formula now, but it's kind of still a little bit different from the question in the course book. I'll make a little bit more derivation. Let's look at this part and this part. They're real numbers, right? Because each term is a real number. they are real number and they are each other's transform. A real numbers transform is itself, say a real number 3, its transpose also 3, right? That's why this term and this term, they are exactly the same. So I can cancel one of them and plug in a 2 here. Then this will be W transpose X W minus 2 times W transpose X transpose Y plus Y transpose. What's the question in the book? Let me have a look. The question in the book. The question in the book is which one? Let me see which one. Quadratic. Didn't see it. It's called a quadratic form. Oops. It's an exercise of chapter 1 or chapter 2. Where can I see the recording of this session? I'm recording it, and I will put the link in the in exercise in material for round 1. 2.45. Yeah, this one. The question is W equals to W transpose CW BW plus C. Yeah, then this C corresponding this Y transpose, right? And this is they're different. This is a lowercase c. This C is corresponding to Y transpose, and the bigger C corresponding to this, right? X transpose X. And this B is it's W. So I should use maybe I should keep this. I should keep this part and cancel this. I should keep this term and cancel this term. Then we'll get. Then here will be. Let's see. Then it will be Y transpose X W. This is uppercase X, right? Yeah. And then this B is corresponding to this not only the but this minus is corresponding to minus 2 Y transpose. Yes, that's the answer to this question. I believe it's correct. If this is possible, how are the matrix and constant related to the feature? Yeah, that's how they're related with this data set, with the entire data set. In this process, you need some, well, basically it's linear algebra calculation. If you are not very familiar, you can go through your linear algebra books. Then I think you will be familiar with that, and then you will see all some machine learning books. But also my personally thinking that I saw some machine learning books. They make some derivation, but sometimes they skip some steps. It's kind of difficult sometimes. But it's always better to refer to the linear algebra book. Okay, thank you, everyone. I think